Broadcasting from the commodity capital of the world, Zurich, Switzerland, this is Insider's Guide to Energy.
This edition to Insider's Guide to Energy is brought to you by Fidectis. Go to www.fidectis.com for more information.
Welcome everyone to the mini-series Next Generation Energy Leaders of the podcast Insider's Guide to Energy. I'm Luca and I will be your host for today. And today we'll not only be talking about our energy issues we're facing in this world, but also the water issues. The guest today works in a startup and they aim to basically solve the world's water scarcity issue. And for that, they need energy. So that's the link there. And I'm very pleased to introduce to you Supriya Matre. Hi, Supriya.
Hi, Luca. First of all, thank you for this wonderful opportunity to talk to you. My name is Supriya Matre, and I work as a research and development engineer in solar thermal desalination at Desolinator. And I've been working here for almost 2 years now.
Okay. So where is Desolinator?
So I'm based in Maastricht in the Netherlands. We have a commercial office in London, and we have our site in Dubai and West Bengal in India.
Okay, we'll come to all that in a second. That already sounds very cool. But maybe let's step back a bit. Tell me how you got into the whole desalination industry and specifically into the startup. What does your journey look like?
I studied my master's in sustainable energy technologies at Delft. That is when I came to know about Desolinator. So who are using solar energy to solve the world water crisis. And that really intrigued me. And that's when I joined Desolinator as an intern, where I worked on optimization of their photovoltaic thermal panels.
But how exactly was it during uni? Did you find it online, or did someone tell you about Desolinator? How did you know about it?
Yes, so I was looking for companies for my internship. So it's like a part of the master's degree where you need to do an internship. And with Desolinator, my main focus in uni was solar energy in sustainable energy technologies. And then with Desolinator, they use solar energy, like I said, to solve the water crisis. And I was really excited to see what they're doing. And that's how I found them.
So we get into the technology in a bit. But maybe tell our audience how exactly you are solving the world's water issues.
So basically, growing up in India, I could see this water crisis physically. Not just in cities, you don't see it, but when you travel in these remote locations, people in these communities don't have water connections, and they rely on water from water trucks, which come in once a week or twice a week at max. And you see these people carrying, walking for miles with these pots of water. And this is just one example of the water crisis. Currently, if you see the water stress map, you'll see regions of South Asia, regions in the Middle East and North Africa, which are under extreme water stress. And the UN has estimated that by 2030, half of the population will not be having access to clean water. Half of the population.
So thank you very much for this. I'm wondering the technology. So we've talked about solar. So how exactly does your plant to desalinate the water, how does it look like? What are the main components of such an installation?
So our main components is the photovoltaic thermal panels, the PVT panels. So our patented PVT panels produce 4 times that of a standard PV panel. So using these panels produce both electrical and thermal energy, which drive the thermal desalination process.
Okay. So you have thermal energy, when I understand you correctly, and electrical energy.
Yes, and that's how we power this desalination process entirely and have distilled water from any kind of salty, brackish water.
Okay. So you can basically take it from a river delta or the sea. Both of them works.
Yes.
So the technology. So I'm imagining or picturing a normal solar PV panel, and underneath you have these black pipes, I suppose, and then you have like a water loop going through the whole system. Is that right?
That's how a normal PVT panel is. Our design is basically standard PV panel, below which we just have a water reservoir, ensuring maximum heat transfer from the panel to this water flowing below. And then this hot water is stored in tanks and then used further in the process.
Okay, very interesting. Do you know how hot these reservoirs get?
So depends on the location actually. If I'm talking about somewhere in the Middle East, it could go, in summers it could go up to even 90 degrees, this water. But then again, we need to maintain this efficiency, because higher the temperature of the PV panel, lower would be the electrical efficiency.
Okay, cool. So so that water then, and I've read on your website, how exactly is it distilled then? Is there like a term, a technical term? I've read about this multi-effect distillation. Could you briefly explain what exactly that is?
Yeah, sure. So then what happens is this thermal energy from the PVT side goes to this multi-effect distillation. Now, this MED process has been around in the industry, desalination industry, for decades now. But we are coupling it with the mechanical vapor compressor, which improves the efficiency of the process. And this MED is in multiple stages. So talking about one stage, it's you have your heated steam in the tubes, on which you have your seawater flow. And because of these hot tubes, we'll have evaporation of the seawater, thus producing vapor and then brine. And this process is continued in stages. And then the steam in the pipes is condensed, and that's how you get distilled water.
And what happens to the brine?
So these stages are basically at a temperature and pressure difference. So each stage is at a lower temperature and pressure from the preceding stage. And so this brine moves along just as the vapor is siphoned, the brine is siphoned to the next effect. And then in the end, that's one advantage of the MED, that the operating temperatures are lower. So your brine is produced at low temperature, and this can be put back into the seawater, into the sea, without harming marine life.
That is fascinating. So so maybe about your role in the startup. What exactly is it you do there?
So currently, I'm working on scaling up this plant. So we are working on a larger capacity model. And basically, I've been working with softwares. And recently, I was working on creating a high-level model with all of these components together and optimize it.
Oh, wow, that sounds really, really cool. May I ask what kinds of software, what languages is it based on? How do they work?
So for the MED, we've been using Aspen. That's one aspect. And then for different sections, we've developed like mathematical models. So even in Excel, we have a lot of them, just mathematical models. But then they're very detailed. So the idea was to create a high-level one with all the components, because otherwise it's going to take a lot of time.
Yeah. So do you guys also, are you still affiliated to the uni, and do you therefore publish papers as well?
As of now, not. So when I was working as, I was doing my internship, I was doing it with the university and the company.
Do you have lots of students still from uni that are doing projects with you?
Yes, we do have 2 interns right now from different universities. And there's, interns every summer. So that's pretty nice.
Oh, that's very cool. So let's get back to maybe what exactly it is you do. So you said you're scaling up the whole plant to make it bigger and basically with software optimizing everything, which sounds really exciting. What are some of the challenges that you face doing this? When talking to people in technology, they often say inventing a new technology is one thing, but scaling up is the real issue.
Yes. So one example I can think of is so a pilot is like 25 cubic meter, and from that we are going to 250, which means obviously the capacity is more, but then the requirements of energy are also equally like 10 times. And then when we talk about this PVT aspect, optimizing it is actually a big challenge. So, I mean, we will be testing these panels in the lab here. Hope it's going to be sunny in the next few months so that we can test the panels, optimize them, and then use that data for the further process.
Do you have lots of like sensor data that you're collecting from these pilots?
Yes. So the pilot, which is currently ongoing in Dubai, we run different tests, and that's not just PVT, the whole of plant, different tests, and then we get this test data from site almost every day, and then we do the analyzation. And with this PVT testing, it's going to be the same. We'll have the test set up here, and we'll have sensor data, inlet, outlet, temperature data, and then analyze the performance of these panels.
Okay, very interesting. So maybe, because we've already touched upon these projects now, could you maybe elaborate on what you're working on?
So the project in Dubai is our pilot plant, which is with the Dubai government. And then we have another one coming up in West Bengal, India. And then the third one is the scale-up that I just mentioned, which we're working on. So at the moment, these three.
Wow. Okay. How many people are at Desolinator doing these projects?
So we're a team of 25.
Wow. Okay.
Oh, it's a diverse team with a diverse skill set. So.
Yes. What skill sets?
So different fields of engineering, business, communication, finance, and it's really fun working with everyone.
Okay, cool. So so in Dubai and in West Bengal, what are some of the differences that you face between? You said Dubai is more the pilot project, and then the West Bengal will be a bigger, more scaled up project in that case.
So the capacity will be same, but then since we're in the commissioning phase, what we're doing is doing a lot of testing, and basically we want to optimize that.
So talking costs of production. When I go to the store here in Switzerland, I buy water for like, I don't know, 3 francs or $3 for like half a liter. But how does the cost of production compare to where you are actually producing your desalinated water in these regions?
Basically, when we talk about water costs, especially considering any remote location, the costs of water, the major part of it is these huge transport costs. Since we have localized water production, we aim to produce this water at $1 per cubic meter.
Apart from your West Bengal and project in Dubai, what's in the pipeline? What are you planning to do in the future once these projects are done and over with?
So the next one will be the scale up implementation. I'm really looking forward for it.
Did you have the chance already to go to these places?
I haven't actually, but most likely I would have to visit site because, like I said, we'll be doing PVT testing. So we plan to do it here in the lab as well as on site, seeing what the difference would be.
Maybe take us through like a normal day, because for me it's still very, I can see here in the background you have a lab with loads of cool equipment. What does a typical day of yours look like?
So typical workday begins with usually team calls. Since everyone is in different locations, we have like a quick update / highlights call going on as to, okay, maybe we got some breakthrough on site, stuff like this. And then following that, we have like different project calls. So for example, like I said, testing data as a team, we like have this call, look at the data together, and then determine what tests we want to do next. And then following that, it's like, okay, if I suggest a test, I need to run some numbers and then send it to you. So that will be the next step.
As I understand, you're mostly now in kind of like the theoretical phase of scaling up with all your software optimization. Do you also talk to suppliers to talk about how many parts of each equipment you're going to need and whether they can supply that by that date? Or
yes, so since we are in the designing phase, we've been talking to some of the suppliers for particular equipment. So this is what we are going to need. Do you have these options, or is this possible? So that is ongoing, and in the next few months, I think that will be like a regular job.
Can you already say what technology you're going to use for the photovoltaic panels? Will that be silicon based?
Yes, it's silicon based.
So you're building the solar panels completely yourself?
Yes. So getting the standard PV panels and then making them into these photovoltaic thermal panels.
So maybe, and we're already coming to the end part of our conversation. We talked about your daily routine. What is the most rewarding part of your job, you'd say? What's the part you enjoy the most?
Like I said, we've been doing testing and we have test data. And then we send the site team some of the tests. So when I say this is what I want to test, I have to run some numbers, do some calculations. So if I'm saying this is the flow rate that we need to set, I need to see how the plant will perform and send that data. And when this theoretical data matches with the practical results from site, for me, it's the most rewarding part. Like you can see that, you're getting a step closer to what you want to achieve.
Yes. That's fantastic. I can see that passion in your eyes when you talk about that. What do you think are going to be on the other side the biggest hurdles to overcome specifically in the next few weeks to months?
I think it's going to be this PVT testing, because we are going to have a really short time to test them. And like I said, we need to optimize these panels and use it in the scale up. And it's not just going to be getting data from the PVT and using it in MED. Getting data from the PVT performance, using it in MED, optimizing it, and feeding it back to testing. So this is going to be in a span of 2 to 3 months of sun. So I think that's going to be the biggest challenge for us.
Why is it only 2 to 3 months of sun? Is it just because it's in Europe?
Yes.
Okay. Yeah. So you only have this time span where you have reliable sunshine over here. Do you have any personal goals over the next? Obviously, I can hear that you're really enjoying what you do. Do you have any personal goals in the next few months to years?
Well, in the next few years, I'd really like to make a big impact on society in terms of sustainability. So, for instance, when I think about these remote communities producing their own sustainable water and own power, and because it's remote communities, they'll probably need to, develop that knowledge and run it themselves, which means we are greatly enriching lives of these communities. That's the goal I want to work towards. And also personally, I'd want to live more sustainably. That's also something I'll be working towards.
So you said in these countries, are you also planning to teach them how to maintain your installation then?
Yes. So the one in West Bengal is basically within this community of 5,000 people. And the idea is the female population within these communities will be trained to operate or maintain these plants.
Okay, that's fantastic. One other question that we always ask our guests is picturing yourself a few years ago as a recent graduate, what would you what would you give what recommendation would you give yourself or someone else making their first step in the energy industry, or in your case, the water/energy industry?
So if I think about myself, I'd go back and tell myself, like, if you're passionate about something, don't be afraid to jump right in, because I didn't have like knowledge in thermal desalination or such. But then as engineers, you just keep learning as you go, like absorb knowledge from not just your field, but different fields of engineering. And I think that's how we can make an impact.
Yeah, this has been really, really insightful. And I'm really looking forward to what Desolinator will be doing in the next few months and years. Supriya, thank you very much for being on the show.
Thank you so much, Luca. It was a pleasure talking to you.
Thank you very much. And for our listeners, thank you for being with us. And remember to like and subscribe to our show. And we will hear you next week. Goodbye, and thank you very much.